So guys, we're going to move on in factoring and talk about the greatest common factor. And guys, this is coming from the opposite of distributive property. So keep in mind, when we have distributive property, if I have something like this, then I multiply the 2x times both of those. And that would give me 6x squared plus 10x. So going forward in the distributive property, I multiply each of those things by 2x. But if I'm going backwards, I'm going to be dividing. So here's our question for finding the greatest common factor. What is the highest number or a variable I can divide each term by? That's what we're asking ourselves. Okay, so if I'm looking at this first problem, what can I divide both 27 and 18 by, and what's the highest thing I can divide both of them by? So for example, I know I can divide them both by 3, but I can divide them, there's a higher number of 9 that goes into both of those evenly. So I'm going to divide both of these by 9. And do you see how these both have a c in them? This has c squared, this has c. I'm going to also divide by 9c. So here's what we're doing. Whatever I'm dividing by, that's going to come out in front. That's going to be the number that's in front of the parentheses. And then whatever I get when I divide, that goes inside of the parentheses. So when I do 27c squared divided by 9c, that gives me 3c. 18c divided by 9c, that gives me 2. So I have minus 2. So that's what we're doing when we do the greatest common factor. So a way you can check that, let's say I wanted to check to see if this was correct, then I could just distribute to check that. So I could say that's 27c squared minus 18c. Yep, that's what I started with, so I know I did that correctly. All right, so let's look at this next one, example 2. I'm going to divide both of these. What goes into both 5 and 15? So that would be 5. And each of them have an x, so I'm going to divide each of them by an x. So the 5x goes in front of the parentheses, and what goes inside is what's left over after I divide. So 5x squared divided by 5x, that's just 1x. And then 15x divided by 5x, that's just 3. So that would be my factored version. All right, let's do these next two. So this first one, what can I divide both 5 and 80 by? Well, 5 goes into 80. So I'm going to divide them both by 5, and they both have a y. So I'm going to divide by 5y. So if I have 5y, that goes in front because that's what I'm dividing each of those by. And y squared divided by y, remember that y squared means I have y times y. And if I'm dividing by y, only one of those cancels. So that's why I have just one single y left. Same thing with the 5 and the 5, those cancel. So in the next one, I have negative 80 divided by 5. That would give me negative 16. And again, the y's cancel, so there is no more y left. And then on this one, example 4, I'm going to divide both of these by 4. Now notice this one does not have a c in both terms. This has a c squared, but 80 does not have a c. So I can't divide by c. I'm only dividing by 4. So 4 divided by 4, that cancels just 1, c squared. And then 80 divided by 4 gives me 20, or minus 20. So that's doing the greatest common factor. So we're going to extend that a little bit more. So in this one, I'm going to divide both of these by 3. Notice this one does not have an x in it. So I'm just dividing by 3, and that leaves me with x squared minus 9. And we are actually going to talk about this, what to do with this, a little bit later in the video. All right, so we might come back to that one. In this one, example 6, this looks totally crazy, I know. So here's what I want you to do. Put a little bracket around this. All of this is multiplied. It's one single term. Then I have a subtraction sign, and then I have all of this. So if I had to think about what can I divide each of those red things by, what will I be able to cancel out in each of them? So do you see how they have that parenthesis, 2x plus 1? I can divide both of them by that since they both have a 2x plus 1. So when I'm writing this as a distributive property, it's going to be 2x plus 1 goes in the front. That's what I'm dividing each of those by. And then what goes inside the parentheses is what's left over when I divide. So when I divide, those cancel. And I'm just left with 5x. And then when I divide here in the second term, 2x plus 1 cancels in top and bottom, and all I have left is minus 2. So make sure you're okay with that. So pause the video if you need to, or rewatch that if you need to do that. I'm going to go on to the next one, example 7. This is very much like example 6. I have two terms. Each of them have a parenthesis that's in common. So I'm going to be dividing both of these by 3x minus 1. So when I write this in factored form, 3x minus 1 is my common factor that goes in front of the parentheses. And then what's left over is, what do I get when I cancel the 3x minus 1? So in this first one, I get just 4. And then in the second one, I get just x. So that's what I get when I'm done factoring. And then this example 8, I've got x plus 3 is in common in both of those. So x plus 3 comes in front. Remember, this is what I'm dividing by. And then when I'm left over, I get 4x minus 4. Oh, and I forgot to do something. So back up for a minute. I didn't do this carefully. Notice that I can also divide both of these by 4. Do you see how they both have 4 in front of the parentheses? So I can really divide both of those by 4. 4 and then x plus 3. So what does that give me? Well, I'm going to have the 4x plus 3 in front. Okay, now what's left over? Well, the 4's cancel and the x plus 3's cancel. So all that's left is x. Now here, the 4's cancel and the x plus 3's cancel, so it might seem like I have nothing left, but 4 divided by 4 is really 1. So I really have a minus 1 left over. So anytime things cancel out, don't put 0 there, make sure you put 1. All right, so, and then also make sure you're looking carefully to make sure you're getting all of the common factors. All right, so let's move on to the back. And this is factoring by grouping. And what we're going to do here is we're going to do 3 things. First, I'm going to group the first 2 terms and the last 2 terms. And when I say group, I mean put parentheses around them. And then what we're going to do is we're going to factor out the GCF, the greatest common factor. So do like what we did on the front. And then the third step is we're going to factor out the common parenthesis. That's like what we did at the bottom of the front page on the last slide. So in this one, example 18, I'm going to group the first 2 and the last 2. And then I'm going to say, okay, in this first group, just look at the first group now, what can I divide each of these by? So I'm thinking just 3x is going to come out of there. So that would leave me with 3x parentheses. 12 divided by 3 is 4. X squared divided by x is x. And then 21x divided by 3x, that would just give me 7. All right, now we're going to do the same thing with the second parenthesis. So I'm going to do, it looks like I can only divide those by a negative 2. I'm going to do negative 2 because they both have negatives in them. So I'm going to have negative 2 is out in front, and then negative 8x divided by negative 2, that's 4x. And then negative 14 divided by negative 2 is positive 7. So now they have a common parenthesis. So this is like what we were doing at the bottom of the page. So I'm dividing both of those by 4x plus 7. So what do I get? I'm going to cancel it. I'm going to have 4x plus 7 out in front, and I'm going to cancel those and have 3x left over, and then a minus 2 left over from this one. So those cancel. I just have 3x minus 2. And that's factored. So notice I went from something with 4 terms, and I factored it into 2 parentheses. So we'll do the same thing on number 19, just to get in the hang of it. So I'm going to group first 2 and last 2. I'm going to factor out the greatest common factor. So here that would be 8x. So I would have 8x, and what's left over is just x plus 3. Over here, my greatest common factor is negative 14. I can divide each of those by negative 14. So when I do that, that gives me x plus 3. And then again, I have that common parenthesis. You see them? The x plus 3 and the x plus 3. So we'll be dividing by that. So what does that leave me with? I have x plus 3 in front, and then 8x minus 14 in the bottom. All right, one last thing we need to talk about. This is another factor pattern, and it's called the difference of 2 squares. And the reason we call it the difference of 2 squares is because whatever we're starting with, both of these are going to be perfect squares. And remember, perfect squares are anything that we can take the square root of and come out with a whole number or with a variable. And it's called a difference because they will always be subtracted. So if we see that, then we know that we can take the square roots of each of them, and in one parenthesis we'll have those square roots added, and then in another parenthesis we'll have those square roots subtracted. So let me show you how that works in this first one. So if I take the square root of x squared, that just gives me x. If I take the square root of 49, that just gives me 7. Notice that it's a difference of them. So according to our factor pattern, this would look like x plus 7 and x minus 7. I'm using the actual square root parts in my parentheses. Do you see that? And the only difference is one's plus, one's minus. If it helps you, this is like when we were doing the diamonds, and this would be like if I put negative 49 in the top and 0 in the bottom because there is no x term. So we had a few of these. So if I were to do that, then I would have positive 7 and negative 7. Those multiply to give me negative 49, and they add to give me 0. So that's why I'm doing x plus 7 and x minus 7. Okay, that's where that rule comes from. It's really just a special case of what we were doing last class. So now we're going to apply that to this one because this one's a little more complicated, right? We wouldn't be able to do what we were doing last class on this one. So if I do the square root of 4y squared, then that would just be 2y. And if I do the square root of 81, that would just be 9. So in my parentheses, I'm going to have 2y and 9, 2y and 9. One of them's going to be plus, one of them's going to be minus. And then that's factored. So that's what I was saying on this very front page is on this example 5, if I have x squared minus 9, these are both perfect squares. The square root of x squared is x, and the square root of 9 is 3. So I could break this down even more and make it more factored. So I would have x plus 3, x minus 3. The 3 in front came from the greatest common factor. So that's what we'll be practicing next class.